Okay, so in a new week of our homework assignment, we're given two more problems. But this week's the problem of this week's are basically about the functions of two random variables. Okay, so let's look at the first problem. We're given a random variable x and y, and they're independent. And x is a uniform distribution from 0 to 1, and y it's also a uniform distribution from 1 to 2, and we make z equal to x plus y. So we wanted to know the density function. We wanted to know the density function of z. Well, we need to solve it into we're required to solve it in two ways. And in the first question, we're going to solve it in the convolution way, which is the integral from minus infinity to infinity, the f alpha, actually fx alpha multiplied by fy z minus alpha. Well, to calculate this, the function to be integrated, it's actually very simple. It's either 1 or 0. If alpha falls outside of a certain area, the function will become 0, and we don't need to calculate it. So our main goal is to find the range where where both of these two functions are equal to 1. Okay, so we could write it as, well, the function to be integrated, we could just simply write 1. However, we need to carefully work on the region in which the function it's non-zero. So this alpha, and we take a look at that. When we're talking about fx, we know that x is from 0 to 1. It's non-zero. Fx is non-zero from 0 to 1. So as for the first function, because the variable is alpha, so we get alpha from 0 to 1. And we work the same as I will do the same to deal with the second variable, and we get this is from 1 to 2, so 0 of z minus alpha is from 1 to 2. But take a look at this. We're going to the integration is with respect to alpha. So we need to express the region where both of these functions are non-zero in terms of alpha. So the region of alpha are written, should be and must be written in terms of z, as a kind of a function of z. So we need to solve the area of alpha. So do some transformation of the second term. We could get that alpha is between z minus 2 and z minus 1. So it's actually very easy. We just put this minus alpha into on the right on both sides, and just do the double equality. Just do two solutions of two equalities, and we get this. So now we have that alpha is between 0 and 1, and it's also between z minus 2 and z minus 1. So what's the area of alpha? It must be the common area of these two regions that are expressed in these two quantities. So the lower limit should be the maximum value of z minus 2 and 0. So we can just simply write at maximum value of z minus 2 and 0. And the upper limit should be the minimum value of these two larger, of z minus 1 and 1. So we just say minimum value of z minus 1 and 1. Okay, we get that. So now we get the region. So we're going to do the integration because the function to be integrated, it's very simple. So it's the minimum from z minus 1, 1 minus maximum z minus 2, 0. So we could just simply put it in this way, but there are some there are some other issues we need to talk about. First, this is too complicated because it's too convoluted, it's too abstract. We need to simplify this. So we're gonna look at the area. Basically, we need to find out which function we need to simplify the minimum function and the maximum function. We need to find out whether z minus 1, which is larger, z minus 1 or 1. Basically, we're asking whether z is larger than 2 or not. So when z is larger or equal than 2, we don't equal than 2, and we're gonna get that the z minus 1 is larger than 1. So this one is z minus 1. And similar, we could get z minus, because z minus 1 is larger than 1, so this one equals 1. So, and the second should be z minus 2, which means 3 minus z. And we could do the similar when z is smaller than, when z is smaller than 2. So as for the first term, we're gonna get z minus 1. As for the second term, we could get 0, which means, so basically z minus 1. We're not done yet. But we're not done yet because during the first, because z cannot go from minus infinity to infinity. That's because when we're dealing with the region of x alpha and z is actually the relation of z and alpha are actually located in a two-dimension plane. It's not like we know that alpha is between 0 and 1, but z also have a, just because we did the integration in terms of alpha doesn't mean we can ignore the region of z itself. Just like we're doing a double integration, we could just simplify the region of alpha, one variable, just from a real number to another real number, and the other whose range is from some complicated functions. Doesn't mean we could, okay, back to this. It doesn't mean we can simplify like z could go from infinity. In fact, this is like a function, and z must make that, z must make that, should be such values that this one is larger than 0 and this one is larger than 0 too. So the z must be smaller than 3 and also be larger than 1. So z is between 1 and 3. Okay. So technically, we have already figured out the probability density function of fz in this question.